Good afternoon, everyone. Thank you very much for joining us, whether it's afternoon or morning where you are. Um, we're here today to announce or reveal the xNAV650 product that was launched earlier this month, and we're going to take you through a deep dive into the product and how it can be used. So, I am Paris Austin, the business manager at OxTS, responsible for LiDAR survey at OxTS, and I'm joined today with Jacob Amaker, our product engineer, responsible for the
Hello.
LiDAR survey marketing area. So, what we're going to cover today, part one is around what is the xNAV650. So, some of you will have attended a reveal webinar at the end of December last year. We have a few more details about the product now and some more example data. And how it fits in alongside our other products in the OxTS portfolio. And then Jake is going to take you through how you can use the xNAV650. So some example applications, some example survey data, and some of the other products that we have, software and LiDAR fusion related, that can help you to get the most out of the inertial navigation system. Finally, we're going to point you at the end to some resources that we've created, so some technical articles and some hardware integration guides, and then we've got plenty of time for questions at the end, we hope. So I'm going to start off with what is the xNAV650. So there are four main points about the xNAV650 that we focused on. The first of them is to maintain a very high performance level. So anyone that was familiar with our xNAV650 INS products will be aware that we have achieved the same level of performance with this product, meaning that there's no sacrifice in terms of high-end position or roll and pitch. Heading, same goes for heading as well. The second is a significant size and weight reduction. So we are coming from a 395 gram payload with the xNAV650 down to 130 grams on the xNAV650, and that inherently means we have a much smaller form factor as well. And we'll come on to the specific dimensions later on. The third is affordability. So alongside the reduction in size and weight, we've also reduced the cost to build the system. That is through a combination of cost-effective components and also innovation on the way that we build our IMU. And the core, sorry, I skipped the wrong way. One core thing is reliability at OxTS. So all of our products now run the same navigation firmware. And so that means that any of you who have used our RT product line or Survey Plus product line will benefit from the same navigation engine improvements that we've made over the 20 years of OxTS being in operation. So that will carry through to the xNAV650. And if you are upgrading from a previous product line, the data output will be identical. So just to put the size into perspective, anyone who's used a Hesai LiDAR or similarly a Velodyne LiDAR, which is of a similar footprint, the xNAV650 fits comfortably inside of the 2D footprint of the LiDAR, and in terms of weight is severely less so than the LiDAR now. In terms of how it compares to our other products, we've just got this comparison chart of how the 7 attributes of the product compare. So just starting with the Survey Plus, which we would consider our flagship INS, it has the highest capability in terms of interfaces and performance. So it has 3 serial ports, 3 Ethernet ports, and it achieves the best position and heading, pitch and roll. But that comes obviously and quite naturally at the cost of size and weight, power consumption and affordability. With the xNAV650, we created a product that was effectively a jack of all trades. It was improvement on size and weight, power consumption and price, while slightly sacrificing some of the interface availability due to the front panel that we use and the performance compared to the high-end IMU and GNSS receivers in the Survey Plus. With the xNAV650, we have attempted to push the limits of effectively the size, weight and power consumption of the product, and also reduce the list price of the product alongside that too. That comes at the cost of only one thing, which is IP protection. As a result, we've made the housing as lightweight as possible, and as a result, we are not offering the xNAV650 at the moment with an IP65 rating, but what we have managed to do is not sacrifice any of the interfaces, logging capability, or performance in terms of navigation compared with the xNAV550. So hopefully it should become an even more attractive product than the xNAV550 is today. Just to put into perspective then alongside the other INSs, any familiar users of the Survey Plus or xNAV550 will have the perspective of how large those are. For anyone not familiar, the xNAV550 is about the size of just shorter than the length of the average size hand, and so the xNAV650 fits comfortably into the palm of your hand, and 130 grams is effectively just more than the weight of an apple, and so really is a significant, about 60% reduction over the xNAV550's weight. Coming on to specific values for the specifications then, we have used a U-Blocks GNSS receiver in this new product, which has quad constellation as standard. So we're really exploiting GNSS for as much as it is worth at the moment, and effectively getting the best absolute position updates more of the time thanks to quad constellation. So that means that we continue to take advantage of the IMU wherever possible. But if we can maintain an RTK integer position lock more of the time, it means position drift becomes less of a factor. Pairing that then with the position and heading pitch and roll performance, we're seeing no degradation in performance versus the xNAV550, but achieved in a much smaller form factor. And then because of the different IMU that we are now using, which is an OxTS developed IMU, we have slightly reduced from 10G to 8G on the accelerometer. And some xNAVs also were the 5G range, so there is an extended range there. But we do have an increased angular rate capability. So for any drones that can turn on the spot at higher data rate than we were previously offering with the xNAV550, which was 300 degrees per second, there is a slight benefit with this increased range. And then we've managed to effectively maintain all of the interfaces that are currently required to interface with LiDAR and also camera. So we have Ethernet for data transmission and logging. We have serial RS-232 for NMEA time synchronization, or we also have two triggers. So you can configure the xNAV to either output a trigger to trigger a camera device, or you can trigger it to log events as an input to log the timestamp when a camera shutter release was executed. We can output up to 250 Hertz as well, but the standard output rate is 100 Hertz, and that's more than enough for most survey applications where georeferencing is taking place. And then one of the key attributes here is the 130 gram weight of the INS, and the form factor you can see here in terms of height, width and length is severely reduced versus the xNAV550 and other INSs on the market for the same performance level. And then on the power consumption and power input range, it's a wide input range. So especially on UAVs, some of which provide a 5 volt output from the landing gear supply, but also a 12 volt power battery will be more than sufficient to power the system. And a lower power consumption means that in any power restricted scenario, for example, on a UAV where flight time is dependent on power consumption of the payload, that reduction from 9 watts to 4 watts from xNAV550 to 650 is going to mean you can fly longer and further as well. 32 gig of onboard storage as well means that we can log all of the raw data of the INS, and in some scenarios, depending on the LiDAR data rate, we can log LiDAR data directly to the INS. So what that means then for UAV, I think I've touched on it already in some parts. The size, weight and power focus of this product really makes it a very viable tool, especially when you're considering combining an INS and a LiDAR onto a UAV payload and coming in at well under 1 kilo, which is a requirement for a lot of flights without a specific license for the UAV payload. The small form factor obviously then means as well that it's easier to mount onto the drone and can be installed in a tighter space. And we have easy access to the front panel for the dual antenna installation. So all systems come dual antenna as standard. And we have that large gyro range. So depending on the size of your drone, the smaller the drone, probably the faster it can rotate because of less inertia to turn the system. And finally, that onboard data logging means that if you're using a 16 laser LiDAR, you can easily log that data directly to the INS and have no need for additional data logging on board. So there's an additional saving on weight that you can make there. Similarly, but in contrast to the suitability for UAV mapping, mobile mapping on land is also benefited by the xNAV650's introduction. Quad constellation as standard means that urban environment data collection can be better for a higher percentage of the time. We also can take full advantage of OxTS's tight coupling navigation engine, which means that in poor GNSS conditions, the IMU can be used to generate a more reliable and more robust position output. And then the range of interface options, synchronization with LiDAR and camera, means that you can easily integrate the hardware with other sensors on the vehicle, whether it be Velodyne, Hesai, or Ouster LiDAR, which we're compatible with and have hardware integration guides for, or whether it's something like a Ladybug camera, which needs a basic NMEA output to timestamp the camera imagery. Performance is always going to be key as well for mobile mapping applications. So the better the performance of the INS, the longer the distances you can work to. So this position accuracy and pitch and roll, as well as heading, is very important to working at longer ranges. And then, as I said earlier, because the system runs the same firmware and outputs the same NCOM file format, xNAV650 is compatible with all of OxTS's post-processing features. So the combined post-processing forwards and backwards, the PPK, some of our other features like advanced slip and advanced smoothing, they're all compatible with this new product straight out of the box. So Jake's now going to, we've got a poll question before I hand over to Jake. We're just interested, and we'll share the data once we've posed this question, but which vehicle are you interested in using this system for your data collection? So I'm just going to launch that poll question, and there are 5 options. Hopefully they're self-explanatory, but if there is an other vehicle that you are interested in, then by all means let us know, and we can maybe answer that in the questions box at the end. Maybe it's a boat or other vehicle that isn't one of the 4 in the list. And I'll just give that maybe a minute. So we've just had 30 seconds. Okay, so I'm going to close the poll now and we'll share the results. So you can see highest percentage of people, the reason the percentages won't add up to 100 is because you can answer more than one checkbox, but the overriding vehicle is car, but drone and other. So if anyone did answer other, then please do let us know in chat what the vehicle is, and we would be able to help you understand if there are any special requirements for it. And similarly, if there's any question marks around how you would install it on any of these vehicles, then just let one of us know. So getting back to the content, I'm just going to hand over to Jake now, and he's going to take you through how the xNAV650 can be used.
Yep, thanks, Paris. So let me just take back control. Okay, so how can the xNAV650 be used? So we're going to talk a bit more about how it's used with particularly survey devices. So first of all are the interfaces. So it's very important for us and for our customers that the xNAV650 is natively compatible with as many survey devices as possible. In general, survey devices require NMEA messages and time synchronization. And we offer a range of ways to get these messages to the survey device. So NMEA messages are available over serial and over Ethernet. And we'll show you on the next slide what that means and how that looks like. So differential corrections. So these will be getting your RTK centimeter level corrections. In real time, you can get these via radio or an onboard ntrip client. The time synchronization can be achieved using PPS, which is the traditional way, or PTP, which is really making its way into the survey market. And we also have a range of different trigger options. So if you wanted to, say for a camera, take a picture every 10 meters, something like this, we've got a range of different options for that with the input and output triggers, or you can know exactly where the survey device was at when it took a picture, something like this. And this is really all you need for it to be natively compatible with most cameras, most LiDAR, and a whole range of other sensors. So we are proud to say that we are one of the few INS providers who offer a PTP for time synchronization. And this has been launched with the release of the xNAV650. And I'll show you now what that really means. So before, without using PTP, so PTP sends time synchronization messages over Ethernet. Before you could use PPS, you would have to do some manual wiring. So we've got a diagram here of a user cable of the xNAV650 and what wires you would have to take from that user cable and wire them directly into the interface box of a LiDAR. I think this is a HESI LiDAR diagram. You can see it requires some work. It's not too complicated, but in comparison to Ethernet, you can see that it works essentially straight out of the box, sending all the messages that are required over this Ethernet connection that the LiDAR can receive straight into the interface box, or indeed you could make a direct connection between the two. And so much simpler connection. And really we're seeing in the survey market that this is becoming more and more common. So we're quite happy to announce that we offer this on our devices now. So if we look at some example applications, in general, survey applications are those where you need an accurate time, position, and orientation. So if we look at a range of different things, we've got high precision applications that focus on the precision. So if you remember, Paris said that we have the 2 centimeter global position, and we've got 0.1 degrees in heading accuracy and 0.05 in roll and pitch. And this is more than enough for a range of high accuracy or high precision applications, such as filming, for example, or different test environments. And remember, the GPS time is also highly accurate. You're not going to get more accurate timing than GPS. And then if we move into longer baseline applications, so a long baseline would be essentially if you're doing a survey over large geographic areas, so over several miles. The problem with other navigation devices would be that the further you go, the more error is introduced. But if you have 2 centimeter global GNSS positioning, then wherever you are within 2 centimeters of your, or the INS knows it's within 2 centimeters of its true position. And so you can do long baseline surveys, no problem. This also plays into repeatability. So of course, if it's within 2 centimeters and you just want it repeatable to 2 centimeters, then that would be all that is required. But also we offer something that I will talk about soon, a bore site calibration. So calibration will also play into how repeatable the data is. So for things that are need to be highly repeatable, so say if you're watching over crops and you want to do a short drone survey every week, say, and to look at how the crops are growing, or on a cliff line and see how the cliff is receding, or something like this, you would need that absolute positioning to high accuracy, and also a highly precise calibration in your setup, so the angles between your INS and your LiDAR or camera device. And then we have some that are more in the middle that are making use of all three of these. So we've got things like road surveys, we've got bridge surveys, which would be typical applications that are long baseline. They have to be repeatable because you're looking at differences between surveys, and they also have to be high precision. So you might be looking at lampposts or drains or whatever it might be that have to be known or seen to a resolution of a few centimeters. So something I'll just touch on is the post-processing that we offer. So we have a range of software called xNAV650, and we offer this for free with all of our INS devices. We don't believe in charging for necessary or mostly beneficial software. So we just talk briefly about what this gives you. So you can view and analyze and troubleshoot your data both in real time and in post-processing. So you're able to view the data that's coming in from the device in real time to make sure that you're not wasting your time with your survey when you get back to the office. The data that we also output from the INS has a very wide range of different diagnostic information that you can use to really understand if you're getting the data that you need. So we automatically find RINEX files. So these are files from public base stations that are going to get you your centimeter RTK accuracy that you really require if you're doing a high precision survey, especially LiDAR survey. That would be quite strictly necessary. And we also have the ability in post-processing to change and improve configurations. So you don't have to worry if you get that wrong in the beginning. Almost everything can be changed in post-processing and the data can be retrieved. Some other post-processing software that we offer that is separate to xNAV650 is OxTS georeferencer. So this is specifically for LiDAR applications, and it's going to essentially, with a LiDAR, make a full survey solution. So you've got your INS, which gives navigation data, you've got your LiDAR, which is your survey data, and then OxTS georeferencer. The idea is that it will combine the data from those to get your final solution, which would be the point cloud that you want, that you would then go on and analyze. So there are various things to mention about georeferencer. So it offers a formula to estimate the errors and uncertainties in point positions in the point cloud, and I'll show you on the next slide what that might look like. The bore site calibration that I've already mentioned, so it's very important that the hardware setup is precisely calibrated between the INS and the LiDAR, and we offer a data-driven method of doing that through OxTS georeferencer. And it's very simple to create point clouds, but also a range of options to get the point cloud that you want to get out. So you can, if you wanted to specifically analyze retroreflective points, as many applications do, then you can look only at those. You can look at a range of distances, or even using that formula for the uncertainty, you can process only points that are as accurate as you want them to be. So we work, currently OxTS georeferencer works with Velodyne, Alster, and Hesai LiDAR, but we are also developing many new LiDARs coming into OxTS georeferencer. So the idea would be that as many potential survey applications can be dealt with OxTS georeferencer as possible. And here is a view of that formula that you can see given in the point cloud. So this is a scalar field of the uncertainties being displayed. So in blue is the highest accuracy points, which are on the road, which would be closest to this the vehicle. And then it goes green, yellow, orange, and red. And so you can see where the INS has, or rather the car has driven under this tree line here. It has lost satellite signals, and so it's lost some accuracy. And you can see that in the point cloud there. And of this very useful, you might want to remove inaccurate points from your point cloud, or you might want to identify where you ought to go back and resurvey. So you could look at this and think, I need to resurvey here, and then you could drive back in the other direction. There's no tree line on this direction, and so you can get all this in blue and green as well if you did that. So we've got some example data now. So we've got a road survey that is using the xNAV650 and an Ouster LiDAR. It's also using georeferencer and the boresight to get this data. So this is a mobile mapping vehicle, a car with the LiDAR and INS on, and it's also using the PTP time synchronization. So no major work had to be done to get the INS and the LiDAR working together. So here are some more pictures here. You can see it's hard to get great pictures of a road survey because it's just in one direction. But you can see the high definition that you're getting in the point cloud, the repeatability also. You can see, for example, the branches on these trees. So the LiDARs in general are easily capable of capturing such details, but the real difficulty is adding up the different frames of the LiDAR, which pair up with navigation data from an INS, and that's what georeferencer is doing. And so you have to have a very highly calibrated setup, otherwise the frames are going to start blurring into each other. So as mentioned, it's using various different aspects that the xNAV650 offers, or rather OxTS offer. So we're using the boresight calibration to make sure that the hardware is calibrated well. PTP, as already mentioned, so it's a very flexible and speedy way to get the hardware set up and going. GNSS absolute positioning, so we mentioned about long baseline surveys. So road surveys typically would be the long baselines. So if you wanted a repeatable road survey, you would need GNSS instead of, say, a SLAM algorithm or something like this. And also the error estimation. So we already said how this error estimation can show you exactly where you need to resurvey or where you might want to get rid of points that are not accurate enough for your use case. Here is a second example. So this is a bridge survey done with the xNAV650 again. So this is using a Velodyne LiDAR, and again using georeferencer and the boresight calibration. And this is done on a drone, and so it's using the onboard data logging as well. So again, you can see the very high definition that you're getting on here. You can see the railway tracks on this bridge. You can see the telegraph wires. You can even see these steps going up to the bridge on the right here. So this is quite an ideal kind of infrastructure survey that you might want to carry out. And this is making use again of the boresight calibration. So to get data that looks like this, it needs to be highly precisely calibrated. But it's also using, as Paris mentioned, the data logging, the low weight and the low power consumption and the low form factor are all playing into how long the drone is able to stay up in the air and how long it's able to fly around the bridge to get as many different angles as possible. And the post-processing, so we're using OxTS georeferencer and also a couple of things from NavSuite that would improve the data. So we're going to use this opportunity to announce that there is a new release of georeferencer coming very soon. OxTS georeferencer 1.4. So georeferencer was released last year. At the start of last year, we've released another version late last year, and we're now hoping to bring one out in the next 2 months. So first of all, this is going to have the full range of HESI LiDAR. So remember, we're working currently on developing a whole range of different LiDAR to be compatible with georeferencer. And if you have any LiDAR that you want to use the xNAV650 with georeferencer, then just do get in touch, and we will we'll get it onto our list of LiDAR that we want to get in. We have an enhanced hardware visualization. So something that can be quite tricky is to get the angles between the LiDAR and the INS correct. And it can often be very difficult to understand what's going wrong and to troubleshoot your point cloud creation if you don't have the right angles. And so this is a really helpful tool. And we've also got a couple new processing options and ways to visualize this. So you can see a map, Bing map of your trajectory where you've gone and surveyed, and you can also see a overlap of your navigation data here in gray and your LiDAR data in red. And so you can see where they overlap, and you can choose a start and an end time. So if you only wanted to survey specific sections of your survey, or if you only wanted to make those into a point cloud, then you can select those, and you can see exactly where the times correspond to on the map. So that will be OxTS georeferencer 1.4, and we'll have other releases later this year as well. So we've got a second poll question here. So I'll just launch that. Okay, so which of these following solutions are you interested in following this presentation? So I've got the Survey Plus, which is a higher grade INS, and we've got the 650, of course, and then we've also got OxTS georeferencers. So that's for specifically LiDAR applications and the bore site calibration that goes with that. Okay, thank you everybody for voting in this. So I'm going to hand over back to Paris now.
Thank you, Jake. So I don't know if I've got control of the presentation. So xNAV650 is available now if you want to place an order or have a demonstration system to trial the hardware and the data workflow. We can also provide software demonstrations remotely online. If you want to schedule one of those, then just let one of us know or email info@oxts.com, and we can provide quotation information via our local distributors around the world as well. So there's a few other points that we want to just touch on that support the xNAV650's launch. Jacob and some other team members in the support department at OxTS have done some really high quality support technical articles so that you can get not just in-depth guides on how to use the software, but also how to physically integrate the hardware device with the OxTS INS. So we have full hardware integration guides for Velodyne VLP16, which is also holds true for other Velodynes within the VLP product range. We've also got integration guides for the Ouster and the HESI LiDAR, and we will continue to improve that content and extend it to other LiDAR in the future as we improve and increase model support within the georeferencer software. And also we've got really good step-by-step guides on how to do the bore site calibration and the georeferencing workflow. We also have a really advanced technical team, so get in touch with us if you have any challenges that you're facing in terms of data collection or a specific application that you're trying to execute that isn't just your standard mobile mapping or UAV survey, and we'll be able to help you in that regard as well. And like I said, we're on the verge of publishing kind of updated versions of all of our LiDAR integration guides, so that you can get up and running as soon as possible and spend less time troubleshooting where something is going wrong. They can all be found on the OxTS support site, so you can see the link at the bottom, but if you just Google OxTS support, it will come up at the top, hopefully. So we also have some other brochures that are available. Jeff has prepared the xNAV650 datasheet as a handout that you can see on the right-hand side in the GoToWebinar toolbars. You can also go to the product page for the xNAV650 on the main OxTS website, and you can download all of these resources in the resource tab of the product page. So you do go there, and you can also see some example data there as well, with some details around which INS was used to collect that data and which LiDAR and what processing techniques as well. So that's it in terms of content that we want to present today. If anyone has any questions, then please do type them in the questions window of the GoToWebinar section on the right hand side. We've got plenty of time to answer them. I think I can see a few are in there already. So I think, Jake, if you want to read them out, then we can get going. And if anyone has any that they haven't put in there now, then type them in and we'll answer them at the end.
So will CAN output be available on the xNAV650?
The answer to that one is no, purely because we have a limited number of physical interfaces available on the pinout of the xNAV front panel. So we have the power, obviously, Ethernet, and then digital signals. So that makes up the PPS output, and then two configurable input-output signals. And those can be configured as either camera inputs or outputs, or wheel speed input.
Well, that ties into the next question, which is, will a wheel speed sensor be available?
Yes, so you can absolutely use a wheel speed sensor. We recommend and have always worked with a Pegasun wheel speed encoder, and we recommend a high resolution. So we've always used that 1024 pulse per revolution encoder, because that gives a sub-centimeter update resolution and can really help to maintain centimeter accuracy when GNSS drops out.
It's got a question here about using multiple sensors at the same time, so ZNF LiDAR and 4 cameras. In this case, they ask, will we need to create a splitter to use PTP?
The answer would be no, because PTP is a broadcast message to a specific IP address. So as long as the devices were all looking on the same IP address and port, which is a UEE standard, they would all be able to effectively take advantage of the PTP that was on the network. So with the xNAV acting as the PTP master, those other sensors would just need to be configured as PTP slaves, and they could all as long as the network switch was PTP compatible, which is a requirement to ensure that time latencies are not introduced into the local area network, then it's absolutely compatible with multiple sensors without the need for a splitter. The network switch effectively would be the splitter.
Okay. So we have a question about challenging GNSS environments. Have we thought about integrating LiDAR with inertial SLAM?
Yes, definitely. In the short term, we have our tightly coupled navigation engine, so using the IMU's accelerations to ensure that we don't take indirect line of sight GNSS signals or heavily interfered GNSS signals into the final solution of the navigation output. But it also means that we can take advantage of less than 4 satellites when we're in a heavily urban environment. So we can continue to navigate in 3D space. If at some point we've had more than 4 satellites, we can drop to 3, 2, or 1 satellites and continue to maintain a position lock thanks to the single satellite aiding feature of GXIX. But yes, we are thinking about and investigating LiDAR aided SLAM solutions alongside using GNSS. So trying to get the best of both worlds effectively.
So we've got a question here that I will answer. So can we show the cable that will be provided with the unit? Yes, of course. So I will send you an email to the person who asked this question with the cable diagram in there. Also got, is georeferencing possible to add CGP where it is not possible to survey again? Sorry, I'm not reading it correctly. So in georeferencing, is it possible to add CGP where it is not possible to survey that area again? For example, a long tunnel with an internal GCP?
Ground control point, yeah.
Ground control point, okay, yeah.
So in georeferencer directly, it's not a feature that we have. That would take place in a third-party point cloud software after you've georeferenced the original data. But one option is to set the origin of your LAS file that is generated to be the location of your ground control point, so that your 000 marker within the LAS file has that global coordinate origin of your ground control point. That would be one way of doing it. But if there is a requirement for that kind of feature, then by all means get in touch with us, email myself or Jake or info@OxTS, and we can kind of discuss that feature requirement in more detail.
Yep. And we've got a question here. Do you need a base station for the uncertainty in position to be 2 centimeters?
Yes, absolutely. So you would need to either have real-time corrections, so a radio link to your base station, or n-trip corrections. So I think you mentioned earlier in the interfaces part of the presentation that we have an n-trip client functionality within the xNAV's firmware. You would just need to provide a mobile internet connection to the Ethernet port of the xNAV, and you can get corrections in real time via that method, or you can provide corrections via the RS232 pin of the xNAV, or you can provide corrections in post-process with a RINEX file, and you can use the PPK capability of the NavSolve software and get the tightly coupled PPK solution.
Yeah, so we've got another question. So is it possible to send out heave data in real time for marine applications with multi-beam?
Yes, it is. So we may have mentioned previously our binary file format is called NCOM, but we also have a marine format, which is effectively that exact same data format, but with a heave output as well. And the xNAV650 can output that heave both in real time and post-process.
So I think there's a final question, at least for now. Is a full version of the NCOM available?
Yes, so we have two. We have effectively a survey-focused data output, which provides time, position, and orientation, as well as all status messages required to georeference in OxTS georeferencer and other software. So as long as you have those 7 messages to provide time synchronization and full 6-axis location, then you can georeference all sensor data. But if you also need accelerations, angular rates, velocities, things like that for other applications that are more specific or more niche, then we have the ability to output those, and they're an optional feature code that we have on the system.
Yep. So that's all the questions that we have for now. So if anybody does have further questions, please do email us and we will get back to you as soon as possible. Or there's plenty of information on the website or the support site for more technical questions as well.
Brilliant. So thank you all for your time, and thank you, Jake, for presenting the content today. Like Jake said, get in touch if you have any other questions, and one of us will be in touch to help you out. But hopefully this has been helpful, and check out the product page for any more information. So have a good day, and we'll hopefully speak to some of you soon.
Okay, thank you, everybody.